Okay, so what we're gonna do is implicit derivatives. Implicit derivative is it's very important. So implicit, so it looks like this. Implicit derivative. Derivative. Okay, implicit derivative. Now we're gonna say why do we need an implicit derivative first? But first of all, what is explicit derivative? So explicit versus implicit. So the whole time that we're doing right now, it's always explicit derivative. So whole time we're doing is explicit. So for example, we always have a y equal to something. For example, all the equation we did is always y equal to x squared. And then we take a derivative of this. And this is actually kind of implicit, but dy dx equal to 2x. And that's it. The problem is always have y equal to. Now implicit derivative is a little bit different. Implicit derivative here is not always y equal to. So for example, when do you use implicit? Is when you can solve a y. That's a very general term when sometimes you cannot solve a y. For example, like say y to the third power, or the mixed terms, right? Mixed term like x y squared, or sine of x plus y. Those are all good indication that you should use implicit derivative. Now I'm going to show you how implicit works, but it's going to be very fast and you probably don't understand that. But xy is equal to 1. And we're going to do it two different ways. We're going to do explicit first. Explicit means xy is equal to 1. So explicit means you have to solve for y. Well, if I solve for y, then that's going to be 1 over x. And of course, I can take a derivative of that because that just means x to the negative 1 power. And if I take derivative with respect to that, dy dx is equal to negative 1 x to the negative 2, which is negative 1 over x squared. So dy dx, which is the derivative, is equal to this. Dy dx is all the things we're looking for because dy dx is slope of y, right? Or also known as a f prime of x. This is something that we need always looking for. We're looking for dy dx or f prime of x. In this case, I'm going to show you how to do implicit. So how do I do implicit? Now, you're going to have a lot of questions after I did implicit derivative, but it's okay. Don't worry about it. Just see this is what implicit look like, and then we will teach you how the detail works. So implicit is going to be, I'm going to take d to the dx of x times y. That's equal to 1. Sorry, this whole thing. Okay, we're going to take d to the dx of x times y equal to 1. And in this case, there's a product rule, so there's a derivative of x at x is going to be 1 times y plus x and then dy dx is equal to 0. You probably have a lot of questions right here, and it's okay. X dy dx, no, we're not going to answer your question right now. It's not because I don't want to answer it. I just want to show you the difference. And you should get the same answer. So you move the y to the other side, you got negative y. And then dy dx is equal to negative y over x. And you probably says, hey, look, you say they should be the derivative. Derivative should be the same. But as you see on the other side, I got negative 1 over x squared. On the right side, I get negative y over x. And you're like, wait, that doesn't make sense. So how does it make sense? Well, let's change this. Let's change this y equal to 1 over x again. And what we're going to do is we're going to change that to negative 1 over x times y. And we're going to replace that y here. So it's going to be negative 1 over x times 1 over x. So it'll be negative 1 over x squared. So there we go. Implicit and explicit derivative, they are exactly identical. Now dy dx is what we're looking for, because we always been, for the past 3 weeks, we've been looking for dy dx. We've been looking for f prime of x. There is no other thing I'm looking for right now. So except dy dx, except we do it with implicit derivative. Now you're gonna be like, well, most of the functions are always y equal to, right? Most of the function you ever see is always y equal to secant square of x, y equal to tangent square of x. There's no other time I need to use explicit. When's the time I use explicit? For example, you have this, x squared y plus y, y squared is equal to 1. So then you look at this function, you says, is it possible for me to solve for y? No, because I can take out y, right? That's going to be x squared plus y, right? Equal to 1. If I move to the other side, you're like, shit, I'm stuck. Right? I still have y on the other side. That's not the goal. The goal is to make sure y is equal to a function just purely x. But at the same time, you can say, well, what happened here? We can actually do implicit derivative. But before I do implicit derivative, I'm not going to show you how to do it on equation. I'm going to show you how to do it on expressions. And that will answer a lot of questions that what we did earlier. So this one is no way for you to solve for y. Therefore, it has to be done implicit derivative. Some people say that's tedious. Yes, I agree with you, but that's the only way to get through these functions. So let's just say if I want to take d to the dx of x cubed. We know d to the dx of x cubed is 3x squared, right? We know that. But what technically did happen is this.
Is it not dy over dx?
No, technically there is 2 layers, right? The 2 layers, what happened is you're going to do a chain rule. If you do the chain rule here, if I take a derivative of x, respect to x here, then you should end up have something like invisible. Invisible, what I mean by invisible is that this dx over dx. Why is invisible? Because you have to take a derivative of x, respect to x, as a chain rule. But dx over dx we know is 1 because numerator and denominator are the same. So we could write down this as 3x squared. So, but normally we don't see that. But why does that matter? Because if I do d to the dx on y to the cube, what will happen? Well, I'm going to get 3y squared just like before. Now remember, those are 2 layers. Now I have to take a derivative of y, but with respect to x. So therefore, that comes to that famous term of dy dx, because the dy dx is present due to the chain rule. That's why we learn chain rule before we do an implicit derivative, because hidden chain rule kind of happen. It's just x, you're not going to do anything about it. Dx over dx, I don't have to write it. It's just 3x squared. But with a y, anytime you have y, then you're going to get dy dx. Does that make sense? Yep, Xavier?
If we're using chain rule for that very top equation for x cubed, why don't we multiply by? I'm sorry. You know what? Never mind.
No, that's okay. What's your question?
I was gonna ask why don't you multiply by the derivative again?
Yeah, I did is dx over dx though, because we taken derivative of the x respect to x.
Oh. Okay.
So therefore, it's essentially 1. Therefore, I don't need to write down 1. That's why the whole reason when we take derivative of x squared or x to the 4th, we never had to write down that 1 because that's not necessary. Now, if I were to take derivative of this, d to the dx of x squared plus 2y, then just pretty easy. 2x plus 2, and that dy dx term show up. Anytime you have y, you're going to get dy dx.
Oh, and so we usually always put that on the side?
Yep, you always write down multiplication of dy dx. Not plus, but times dy dx. Now, I'm going to put this d to the dx of negative 3x squared y to the 4. You're like, oh my goodness, there's a lot of things going on. Yes, they are. There was constant multiple rule, there was a product rule, and there was a chain rule happen. They all kind of work secretly with each other. So first of all, let's take a constant multiple rule because it takes the constant outside. And then I just d to the dx of x squared y to the 4. And what I'm going to do is I put a negative 3 and I put it this parenthesis. And that's very helpful for a lot of situations. But it turns out there's a product rule. X squared, which is 2x. And now just leave it a y to the 4th alone because there's a product rule. Plus x squared times 4y to the 3rd, right? And what's the most important thing? dy over dx.
Why did you multiply d over dx times?
I just I didn't multiply. I take the negative 3 in front of d to the dx because that's a constant multiple rule. That means I don't have to worry about a constant. I just worry about taking the derivative of the variables. In this case, it's x squared y to the 4. But in this case, if I do x squared y to the 4, there's a product rule exists. And that's how I got this part here, because there's a product rule. Anytime you take a derivative of x, it's going to be 1y plus x, and you have to take a derivative of y with respect to x, therefore you got dy dx. Let's go back to explain to that one. Now it makes a little bit more sense. Now we're going to actually try a problem. Thanks, Ethan.
Honestly, I'm more confused.
Thanks, Ethan. All right, let's try it. So 3x squared plus 6y squared minus 2 times x squared y to the 3rd. Okay, so what I'm going to do is I'm going to take a derivative of this. I'm going to take a derivative of this respect to x. And if I take a derivative with respect to the x, what's 3x squared? Yeah, see, you guys are geniuses. Plus 6 what? 6 times 2 or y squared. So what's the derivative of 6y squared? dy dx. Good. And then remember that negative 2 just kind of sit in the front. The negative 2 is going to be sit in the front. That put a parenthesis afterwards. Because I just worry about the x squared y to the q, and I'll just do negative 2, I'll just distribute it. And usually, mathematically speaking, it's much easier to do that. So I'm going to do x squared y to the q. So what's the derivative of x squared y to the q? 2x y to the q.
Plus 3y squared dy over dx times x squared.
Plus x squared times 3y squared, and then there's a dy dx, right? You just did the hardest part, and that's it. It's equal to what's the derivative of 10? 0. And all you gotta do is distribute this, and then 6x. Sorry, let me use black. So that's gonna be 6x plus 12y and dy dx. I'm not gonna write that in a second. I'm gonna write that in a second. So minus 4x y to the 3rd minus 6x squared, I think, negative 2 times 3, y squared equal to 0. I'm going to dy dx because I need to color code this. Does that make sense? I just distributed negative 2. So negative 2 times 2 is equal to negative 4x y to the q. And negative 2 times 3 is going to be negative 6x squared y squared dy dx. Now what happened is I'm going to move everything else non-dy dx to the other side. So this and this is going to move to the right side. To the right side. So then I'm going to get 12y.
Wait, sorry, what did that say?
Move to the right side. So therefore I'm going to get a negative 6x plus 4x y to the 3rd. And what I'm going to do is you got 12y minus 6x squared y squared, and the dy dx is different color. So what can I do here? How did I get dy dx by itself?
Factor it out.
Factor out. So therefore, I got 12y minus 6x squared y squared is equal to negative 6x plus 4x y to the third. Then dy dx is equal to negative 6x plus 4x y to the third over 12y minus 6x squared y to the square. So then I'm done. That's what the dy dx is. Now you guys gonna try it. So let me say 6x minus 7y minus 5x squared y to the third is equal to 10x. So I want you to take a derivative of this.
Initially, I'm just close to.
Yeah.
Let's see, yeah.
You got this, man.
Let's see, yeah. How did the 12y minus 6x squared y squared go on the bottom?
What?
How did that go on the bottom? Oh, do you divide it?
Yeah, I divide both sides by 12y minus 6x squared y squared.
Why should we see like with the
What is dy dx gonna mean?
Is it like a notation?
dy dx is a derivative of a function. And the function here is a mixed term, so you cannot take an implicit derivative. So that's a function. Now, what if I want to find a slope at a certain point? So therefore, dy dx is going to provide you a slope.
So why'd you move the just the 6x and the negative 4x?
I moved to the other side because I want to solve for dy dx. I need to isolate dy dx by itself.
But how do you know like which one to put dy dx after?
Anytime you take a derivative of y, then you're going to get dy dx.
Don't even know which one I'm writing down.
It's the last one. Anything.
Wait, can you scroll back up? Please.
So it will impede our measure.
By the time you ever graph this function on Desmo, they are kind of fun to look at. Sometimes they have, they have axis of wedges, and they have a lot of really, really interesting graph. I don't know what a graph look like, but it's kind of interesting.
Minus 5 question mark is your reply?
Robert, you got this? Oh, you look at Desmos? You probably sometimes zoom out a little bit to see how thing works. I mean, I have no idea what a graph look like. There's no way I can predict what a graph look like. On those kind of weird function mixed together, it's very hard to see.
I mean, I don't get it, but I get something. There's something that I get now, and it's like.
You got us, Ethan. You got us. I must start off with this one. Derivative of 6x is what?
6.
6. Derivative of 7y is what?
Negative 7 dy over dx.
There you go. Minus 5, and then I'm going to do derivative. I'm going to do a product rule here. So that negative 5 is going to distribute to that. So what's derivative of x squared y to the cube?
2xy cubed
2x y to the cube
plus 3y squared dy over dx.
plus
x squared.
x squared times 3y squared dy dx, right? And it's equal to 10. And then what I'm going to do is distribute this. 6 minus 7 dy dx minus 10 xy to the 3
Students, you are now dismissed.
minus 15x squared y squared dy dx is equal to 10. Are we okay here? So 6 to the other side is going to be 4. So 10 minus 6 is 4 left.
Oh, no, and then negative 10xy.
So 4 plus 10xy to the third is equal to dy dx. Huh? Minus 6 on both sides.
Minus 6.
Tyson, what's 10 minus 6? 10 plus 6.
I did the hard part, but
dy dx, take it out. That's going to give you negative 7 minus 15x squared y squared.
you pulled in Ethan.
And dy dx is equal to 4 plus 10xy to the third
Understand everything.
over negative 7 minus 15x squared y squared.
Yes, I know.
You got this.
I did all the hard part. Well, wait, so the tutoring after school, like here?
Yeah.
Okay.
Wait,
I'll stay.
how do you put up in decimals?
Huh?
I tried to put in decimals.
I mean, sometimes a function doesn't come up because the number is kind of weird, but let's try it. 6x. What was the equation? 6x what?
Minus 7y. Minus 5x squared y squared.
5x squared y squared?
No, sorry, y cubed. Y cubed. And then equals 10x. Oh, yeah.
I mean, that's not too weird. That's not too weird. This is actually okay. Bye.
Have a good weekend.